In Puerto Rico, green lizards are a foreign invasive species from Central and South America. Without a known predator, this species has been aggressively reproducing throughout the island and generating a problem. For years, the NFPO para la Naturaleza has been contemplating ways to speed up the identification of microhabitats that are ideal for iguana nests. The NFPO has explored the use of image processing in the past. In 2011, they used endoscopic cameras to identify nests, but the process was slow and time-consuming.
Our first objective of this project is to implement aerial image processing, AIP by its acronym, using a quadcopter platform and display the AIP results in a GIS environment. GIS stands for Geographic Information System, and it lets us visualize, question, analyze, and interpret data to understand relationship patterns and trends. We would also like to develop a relational rule to integrate GIS and actual egg nest excavation data with the AIP system to identify potential microhabitats and their respective likelihood of finding egg nests within the habitat. Last but not least, our main goal is to perform field testing and validation of the proposed system.
In this project, we will acquire a quadcopter and a camera kit and develop a multi-hyperspectral lens adapter that allows us to capture spectral information from a commodity camera. Using the ArcGIS model, pattern recognition techniques are used to identify potential targets in the acquired data. The activities planned for the project are as follows. After the equipment has been acquired, the professor will provide initial training on the use of the quadcopter and image and video capturing. The professor will also coordinate training in engineering concepts for the design of the optical spectral instrument attachment. The students as well as the professor will review the literature, implement a design prototype, and integrate the spectral lens attachment to the camera. The system is properly set up, we will proceed to evaluate its performance with controlled field tests. Once the equipment has been validated, we will integrate it to the provided ArcGIS model of the area of interest to identify potential iguana nests.
Time schedule. For this project, we want to make the best out of our time, and for that, we have organized our activities in the following way. For December, we had to acquire all the equipment necessary for the realization of the project, and we have prepared the IAP video proposal. For the upcoming year, in February and March, we have the integration of the camera and the lens. By the end of March 2018, we should have the performance validation of the equipment. In April 2018, the ArcGIS model should be already integrated. And to wrap it all up, in May 2018, we'll be at IAP meeting presentation.
The success of the project will be measured according to the following metrics: adherence to the proposed time schedule, strict adherence to the proposed budget, and the microhabitat map field testing and validation. In conclusion, the project could potentially dampen the impact of the iguana problem in Puerto Rico.